Welcome. Today we will learn the first method that we'll be using to expand binomial expressions, the Pascal's triangle. The Pascal's triangle is simply constructed using simple arithmetic. The first thing that we're going to do is we'll write a 1 like that, and then we'll write ones on the sides. Then we'll add the two ones to give us this 2, and then we'll write ones on the sides of 2, and then we'll add this 1 and this 2 to give us this 3, and this 2 and this 1 to give us this 3. Then we write ones on the sides of the 3's. Then we add this 1 and this 3 to give us this 4, this 3 and this 3 to give us this 6, this 3 and this 1 to give us 4, and we write ones on the sides of 4. Then we add this 1 and that 4 to give us 5. 4 plus 6 equals 10. 6 plus 4 equals 10. 4 plus 1 equals 5. We write ones on the sides of 5's. Then 1 plus 5 gives us 6. 5 plus 10 is 15. 10 plus 10 is 20. And 10 plus 5 is 15. And 5 plus 1 is 6. Then we write ones on the sides. And so on and so forth. That's how a Pascal's triangle is constructed. So now, how do we use this Pascal's triangle to expand binomial expressions? Here's an example. X plus 1 in brackets raised to the power 2. We discussed earlier that it's equal to x squared plus 2xy plus y squared. So how does this relate to the Pascal's triangle? Notice I've written it in this row. So we're going to use this row of the Pascal's triangle to expand that. The relationship is this. We've got a coefficient of x squared there is 1, which corresponds to this one. The coefficient of xy is 2, which corresponds to this 2, and the coefficient of y squared is 1, which corresponds to that one there. Okay, let's look at another example. We want to expand x plus y to the power 3. The answer is x cubed plus 3x squared y plus 3xy squared plus y cubed. How do I arrive at this? Okay, so I've taken the coefficient of 1 there, which corresponds to a coefficient of x cubed there. 3 corresponds to the coefficient of x squared y. This 3 here corresponds to a coefficient of xy cubed or xy squared. And this 1 here corresponds to a coefficient of y cubed. Okay. Next, what's happening here is that if the highest power is 3, then the first term, which is x squared, will be raised to power 3. And then we're going to be reducing the power by 1 as we progress in the series. So 3 minus 1 will give us this 2, and 2 minus 1 will give us a 1, which is the power of x here. And of course here we've got 1 minus 1, which is x to the power 0, and we know that anything raised to power 0 is 1. So there's a 1 there, which in mathematics we usually don't write it. Notice the powers of y are increasing. We've got a 1 there, it increases by 1 to 2, it increases by 1, goes to 3. So the powers of y will be decreasing as the series progresses, and the powers of x will be the powers of y will be increasing as the series progresses. See, there's 1, 2, 3. We're increasing. And the powers of x will be reducing as the series progresses, which is 3, 2, 1, and eventually 0. Okay. Another one. X plus y raised to power 1. Okay, so this is equal to x plus y. Okay, so again, this one here corresponds to the coefficient there, which is 1, and this one there corresponds to coefficient 1 there. The highest power of x is 1, so we've got 1 there, and here we're going to have x to the power 0, which will give us 1, and the powers of y will also be increasing, so we've got y to the power 0 there, which is 1, that's why we haven't written, and then from 0 to the power of 1 there. Okay, this is the same way, x plus y raised to the power 0. This one we've got nothing much to say. We know that anything raised to the power 0 according to laws of indices is simply equal to what? 1. Okay, let's focus on this one and make sure that we understand what we're doing here. So we've got x plus y raised to the power 4, and in order for us to expand that, we're going to use this row here. So the coefficients are 1, 4, 6, 4, and 1. So we've got 1, 4, 6, 4, and 1. Those will be the coefficients of all the terms. And then again, the highest power is 4, so we're going to raise the first term to the highest power, which is 4, and then keep reducing by 1. So we're going to have 4, 3, 2, 1, and eventually 0. And for the second term y, it will be increasing by 1. So we always begin at 0. So we're going to have y raised to the power 0 here, and anything raised to the power 0 is 1, so we won't have to write it. Then therefore from 0 to 1 the power here, then 2, then 3, and eventually 4, the highest power. Okay, so in the same way we can expand x plus y raised to the power 5 by using these as coefficients, and we can expand x plus y raised to the power 6 using these as coefficients. Okay, I'm going to write down the solutions for x plus y raised to the power 5 and x plus y raised to the power 6 for you. I want you to complete this as your homework. Pause this video and complete that, please. Thank you.